Hello and welcome back to the Traffic Safety Research Institute's Innovators Series. I'm Robert Dingus, and it'll be my pleasure to moderate this session today. The mission of the Research Institute is to educate and advance the industry's role in improving roadway safety. Today's session, Driving Safety Forward, Indiana DOT's evidence-based approach to human and machine vision lane marking standards, directly supports that mission. Our speakers, Joe Bruno and Michael Williamson, will share insights from INDOT's research on several key initiatives, including the use of orange markings, contrast markings on concrete, the shift to wider and more durable markings, and the implementation of centerline rumble strips. We hope you find this session informative and valuable. If you'd like to revisit the presentation or explore other sessions from our series, a link has been provided in the chat box for your convenience. Thank you for being here, and let's begin. Michael?
All right, thank you, Robert. So what I'm presenting on is one of the projects we've recently conducted with the INDOT Department of Transportation. So it's titled The Effectiveness of Contrast Markings on Roadways and Orange Markings in Work Zones. So it's SPR 4642 if you're wanting to go and look that up. There's a report available. Um, so Joe Bruno is with INDOT, it was, as you just said, and then I was with Indiana State as a professor when I did this research. I was there for about 10 years, but I've recently made a shift over to Kaskaskia Engineering. So I joined an engineering firm. Okay. All right, so it's kind of an overview of what we're going to be going over today in our presentation. I'll give you kind of a brief overview of everything and in our approach to our analysis. We looked at both contrast markings and orange markings. Um, so it's two separate things. So I'll present some research results on both of those. And Joe's going to get more into contrast marking implementation in Indiana, wider and more durable markings. So looking at the alternatives to raised pavement markers, so help people see the lane lines, and then the pavement marking friction testing program that they have. All right, so kind of the overview and approach that we took for the research part of this. The typical standard literature review is conducted for both contrast and orange markings. So try to identify the current status of everything. So what have people already determined about contrast markings and orange markings, and what is lacking? So where do we need to do more research? What do we need to figure out? One of the other things we looked at was machine vision capabilities. So a lot of cars on the roadways now, and a few years back when we conducted this experiment, we're starting to have a lot of the lane departure warning systems on board. So it lets people know if they're starting to shift out of their lane. Either beeps or gives you a vibration in your steering wheel, or lights come on to get your attention to try to reduce those lane departure crashes, which is where this striping helps with. So we wanted to make sure we incorporated that testing in as well, at least in some capacity, just to make sure we weren't doing something that was going to cause problems on the roadways. We didn't want to put a stripe down if vehicles didn't know what to do with that. And then also we're studying really the driving behavior. So what do drivers do when they go through a work zone and see orange striping or the contrast striping versus the typical striping that's down? As part of this, we had to go through federal highway approval. So it's an experimental process with the orange markings. So it's not something that was available to use. So we had to get permission. Step three, we really got into the data collection. So we're looking at colors of the stripes and, fading, how much should it fade over time through the work zone or through the construction period. Retroreflectivity testing was being conducted, looking at crash data for both contrast and orange markings. We looked at speed data for the orange markings, vehicles, lane position within the lane and the work zones, and then also did a survey of drivers' opinion for our data collection. And then for analysis, we looked at the decay rates of the markings that we were testing, the safety benefits, and then driver opinion. And then, of course, conclusions. So once we get through all of our analysis, what did we discover? So we can report that back. So starting off with our contrast markings, and you're probably familiar with these. already. So it's either a white stripe bordered with a black line on either side of it, typically about 1.5 inches on either side, or it's a lead lag pattern where they have a typical white stripe followed by a black contrast stripe. And they're commonly used on light colored sections of pavement, so concrete. For example, so the pictures I'm showing there, the top one, you can tell it's a lighter colored pavement and it's a lead lag pattern. The picture down on the bottom is the bordered pattern where it's the white stripe with the black mark on either side. And then the map in the center shows the locations. These were around Indianapolis. So we had one kind of on the south end that had been down for 3 years. That'd be on I-65. And then one on I-70, which is over on the to the left, which would be the west side of Indianapolis near the airport, that had only been down for 6 months when we did the analysis. So, of course, we took those things at the time that it was down into consideration in the analysis. And we're comparing this to a national study that had been recently conducted that included data from 5 other states with multiple years. So both of the analysis for um, the contrast as well as the orange markings, we took more of an empirical Bayes approach, or the highway safety manual predictive method approach to identifying what the safety benefit was. So using safety performance functions, taking into consideration ADT. So if it had a before and after period, I was pulling the ADT and the before and the after so that that can be a consideration as well, because we know the more exposure, the more risk of crash. So we wanted to account for that, everything that we could account for to isolate what we were testing. And then also segment length, looking at the expected crashes using a weighting method. So the one location for the contrast was down for 3 years. That got a lot more weight in our final result than the one that was only down for the 6 month period. And then, of course, the overdispersion of the prediction model was taken into consideration as well. And then we observed crashes in our before and after periods. So with this, we were able to go through and develop crash modification factors for the contrast in the orange. So looking at our before period, our expected, our versus our predicted, and then the observed. And you're probably familiar with this. It's been out for a while. Don't spend a lot of time on it. But this is just the approach we took. And then the final result, we're looking at the expected value of the crashes in the after period without a treatment and comparing that to the actual observed. And then that calculates our crash modification factor. So we're doing our best to isolate out just the change that we did to the roadway and what was the safety benefit of that. So for our contrast pavement markings, our target crashes we're looking at are lane departure crashes. So commonly side swipes, fixed object, or overturns. So not looking at traffic was backed up and there were some rear ends. That has nothing to do with the striping. It has to do with congestion. So isolating those few crash types, and then combining the different locations we had together. So we had 11 crashes at one site we were dealing with and 10 at another. And combining that together, we showed a 42% reduction in lane departure crashes. And that compared to the national level CMF, we compared that to a 0.71 versus a CMF of 0.58. So pretty similar results. And the national study had, substantially more crash data. So they had many more sites were included in those studies. So for our orange marking, which is really what the focus of the project ended up being on, past just validating the contrast marking benefit, we again went through a substantial literature review, looked at what previous researchers have done. So where was the lack in research? What did we need to do? Identifying different sites we could go implement this at. We did a survey of the public opinion. So we wanted to know if the public were okay with us changing a striping, putting something new out there. What did they think of that? Testing autonomous vehicles, detection systems, looking at lane position, speed impacts, and then, of course, adhering to the federal highway guidance on this experiment as well. So when we started this, and this has been probably 5 years ago now, only 2 states had completed orange pavement marking research. That was Wisconsin and Kentucky. So we had their published reports to look at as something to kind of build on. So a building block, identify problems that they reported having, so we could kind of learn from that and continue the research on and expand it. Other states that were kind of kicking off at the same time as us were Texas, California, and Michigan. And I believe there's a few more that are also experimenting with it nowadays. So we were all kind of at the same time moving forward with this. So some of the previous research we looked at through our literature review, some had mentioned some speed impacts, kind of a before and after study. One reported an increase overall of about 2 miles per hour in the direction of orange. So putting the orange marking down actually increased speed by 2 miles an hour. Another one said they had a daytime increase with the orange markings of zero point 0.5 miles per hour and a nighttime increase of 1 miles per hour. So not substantially different. Um, and then the overall speeds noted through some of those work zones were about 65.8 miles per hour. And of course, it was posted at 55. So people were going around 10 miles per hour over as they tend to do. Previous research also identified public opinion on markings. Drivers overall preferred orange markings in both daytime and nighttime conditions. So just made them a little bit more aware. And some of the different comments that came out of the surveys we found in literature review, they were more aware of work zone, easier to see. And then some of the, a negative comment was it's harder to see in wet nighttime conditions. So it's still an experimental stripe. I know everybody's still trying to identify the optimal product to put down out there. So for our test sites, we had three. Two were on NDOT roadways. One was on the toll road. We just went up there to do some data collection and really to look at the type of product they were using and see if that was something that NDOT wanted to experiment as well. So the first one was at Sellersburg, which is down in the lower part of Indiana. So it'd be the lower X you see. And then we tried a tape product down there. And then we tried a paint more the center of the state at Lebanon. So that'd be the center mark. And then the one up at the very top of the screen was on the tollway. So at Sellersburg, it's kind of a visual inspection. I had a GoPro camera mounted on windshield, would drive through, collect data through the work zone, so all hands-free and safe. As you were approaching the work zone and getting into where you're going to see, just before lane shifts and the actual work is happening, that's where the orange marking started. And at this location, we used the typical yellow mark on the left edge line and used orange for the center line and the right edge line. This was a tape product that was placed down. So it's kind of you can tell that the orange marking is different, but it was a little bit light colored on the orange um, versus what we ended up going to later on. Problem we had with this orange tape is that it did fade pretty noticeably in a fairly short time period. So on the left, it had been down for about a month, and on the right, it had been down for about 2. So you can still see the lane line, you can still tell where your lane is at, where you're supposed to be, but it's not a bright orange color anymore. Picture here on the left is an example of how much it did fade. So the single stripe to the left had been down for about 2 months, and then on the right there's a double stripe. So this is a point where kind of moving through the stages of construction, they were restriping some things and had placed some. We're able to leave some of the existing tape and then put some new tape down, and you can tell the noticeable difference there between 2 months versus a 2-week exposure. So as part of this, is we tested the color and retroreflectivity. We took readings and were able to kind of come up with a rough decay rate. Installation a couple weeks in, and then it was about 78 days out is when the last point was taken. So being able to identify, what is your minimum level retroreflectivity you'd like to have maintained, and you have a rough idea of how long this product could last in the field. So at nighttime, something else we looked at based on our literature review, one of the previous locations had studied and found that there was an impact of sodium vapor bulbs making the orange appear a different color. So we wanted to take a look at night as well and see what things look like. Driving through about 2 weeks after installation, it appeared to be kind of an off-white color, so retroreflectivity was there, so that the V package is working. About 2 months into the field, it appeared to just, still be white. It was still visible, but what we found was the beads that were used on this tape were a white. beads, so that's why the color was white. As we move into our next site that we looked at on NDOT's controlled roadways, Lebanon is where this was located at. And this striping was put down because they'd had a lot of crashes in a work zone, so they did it as kind of a countermeasure partway through construction. So we'd moved to an orange paint is what we went up and looked at what the tollway was using. So try that instead of the tape that wasn't holding up. The orange paint was matched with an orange bead package that Joe identified, and it was used more as a complementary striping. So instead of replacing the striping that was there, they just put it down next to the existing striping, just to make people a little bit more aware of the work zones and dangers going through it, give them better guidance. Driver view at night, it did appear once you can color, it was very visible. So this was a pretty successful experiment. And a couple of pictures of that site. It's kind of this exit is to a U.S. highway, so fairly heavily trafficked there, and people were crashing into that, kind of like running into that gore area, is where a lot of the crashes or would almost hit that and swerve over and hit one of the barrier walls. So the picture on the right shows the striping. We were off on the shoulder when I took the pictures for safety, of course, but you can kind of see how that's been um, striped to just make people more aware. All right, so as we're dealing with construction, um, typically a short period of time, there's not a lot of crash data, so you can't go out and grab the typical, 3 to 5 years of data before and after. You're looking at a few months. So for this location in our before period, before we had striped it with orange, we had 3 crashes, and then in our after period, so after we made it more visible, provide a little more guidance, we didn't have any more crashes past that point. All right, so as part of this, our one of our goals was to get public feedback, make sure the public is okay with our orange markings on roadways. So we created a flyer and a survey, put a QR code on it, and then this was just placed at a rest area north of the Lebanon work site, which I'll show you in the next. So we were trying to control as much as possible with this one, and just get people that had likely driven through the work zone, make sure we weren't getting a lot of other people's feedback that hadn't. So if you look at the map, dots were right next to Lebanon. That's where the work zone was. So as you progress up I-65, there was a rest area about 6.7 miles to the north. There was one very rural intersection in between there, so it's possible somebody had gotten on there and taken the survey. Overall, we were pretty confident everybody just driven through it that would be stopping there. So placed it around the rest area in various locations, on doors in the vending area, and etc. So if someone was in the rest area, waiting on someone, they could scan the QR code and take the survey. And we ended up getting 70 responses from that site. Um, and it was just a really short survey, 6 questions. I don't like doing really long ones because then people start them and don't complete them, or if they know it's going to take them an hour when they start, they don't start them. So we just wanted to get some very brief public opinion on a few questions. So, and I've got those. I got some graphs I'll run through fairly quickly here. So we're just trying to look at weather condition, seeing if there's a preference based on weather. Unfortunately, nobody went through or reported when it was raining, so nobody stopped and took the survey. So most people went through and it was clear, a few cloudy. Time of day, most of them were daytime. We had very few responses at night, so really can't go in and say that people preferred at night or not. Um, Being able to identify it. So did the orange markings, did they just notice it? We asked them, did you just notice them because it's something new? We're trying to get people's attention going through those work zones. So 88% reported that they did notice the orange markings going through. 12% said no. We asked them if it made them more aware of the work zone. So 80% said yes, it made them more aware they were in a work zone. So we're adding more orange to the work zone. Um, We asked if people thought if the orange markings were more visible than white. 81% reported yes. Asked them if they thought it were more visible than yellow. 82% reported yes. So some kind of key outcomes from that. We had pretty good public acceptance. So Most people were accepting of it, thought it was more visible, made them more aware of the work zone, which is what we're really trying to do, is get people's attention, get them to slow down, be more focused when they're going through an area where there's some dangers they need to be concerned with. And then it's just really increasing the visibility of the striping in the work zones. One of the other things we looked at, because this came up as a point of concern, what's going to happen with vehicle, lane detection systems that are out there. If someone's driving a car and they see an orange stripe, is it going to know what to do or not? Are they going to suddenly get into crashes in a work zone, and we're going to be liable? So as part of the experimental process, when we would go out and do data collection, I was renting a different car that had a lane detection system on it, and would go and test it in the work zone as I was driving through. So just whatever was commercially available at a rental car place, and again, just testing the orange striping. So of course I tested other striping colors on the way there and in and around the work zone. All the vehicles that I tested, and I won't name off the brands or the mix or anything, but 100% detection rate for yellow, 100% for white, 100% for orange. It detected it just like any other stripe, and no detection for the ghost marking. So the stripes that get ground off. Some things to note on that: the ghost stripings, if they tended to be more centered in the vehicle, and the vehicle's detecting kind of out to the edges. A lot of times it's off of the mirrors, the rear view mirrors on the side of the car. Um, so it's going to have the detection system somewhere in there, and that's where it's detecting it. So if it's something more to the center, it's not going to pick it up. And as stripes were worn, so locations I would drive through maybe have been chipped up pretty heavily by snow plows, and they hadn't got out there and repainted yet. Some of them probably only had 50% of the stripe actually there. A lot of it was chipped away, and it was still detecting the stripe. So no issues with that. Um, Lane choice and position. So I placed a GoPro camera on right next to a barrier wall on a barrel, and recorded video at the sites, and then took that back and analyzed it, looking at where the vehicles were within the lane, excuse me, and their lane choice. So we found a nice straight section of roadway, so we weren't didn't want to like take that at a point where people just went through some kind of a lane shift or anything. It was well past that. They were in a straight section. Where were they going to be comfortably located at within their lane? Reserved this during some peak hours, fairly heavy traffic, more of an observational method. So I had grad students at the time when I was a professor helping me review the data, and then looking at how many vehicles were on the left versus the right lane in this two-lane section, and then were they kind of hugging to the left lane edge, the right lane edge, or were they more centered within the lane? So combining multiple people's observations together, we ended up with, for the lane of choice, pretty even. So around 55% in one and 45% in the other, versus right versus the left. One of the projects we looked at in our literature review had looked at lane straddling. So if someone was confused about what lane to be in because of this new striping color, and if you look at the picture down on the lower part, you can really see the ghost marking still. It's very visible. You see the skip dash and the edge line. So someone could be confused and think they're supposed to follow that and be straddling the two lanes, so straddling the orange stripe. But we did not observe that at all in our experiment. And then we had about 0.03% of the vehicles that went through that actually made a lane change in a solid stripe where they're supposed to stay in their lane, but so very few lane changes were occurring as well. Looking at where the vehicle was within the lane. So is it, we wanted to be more centered because then they're further away from striking the barrier or striking an adjacent vehicle, which the closer they are to the center, the safer they are. And observations, we had around in the left lane, around 51% were centered, around 49% in the right lane. So they're both being pretty centered in their lane. And then the remaining percentages hugging to the left or the right. The right lane, for some reason, 33% versus only 19% hugging the edge line. So it's kind of unexplained there. We did a spot speed study as well. So you need to take at least 100 samples in a direction in order to be statistically significant or sure of your results. So we took 200 samples, collected these during a PM peak period, and just trying to identify if there's a possible speed reduction benefit to the orange marking. Keep in mind these were posted at 55 miles per hour. At the location both locations, the northbound was striped orange and the southbound was striped just with the typical striping. So we kind of had a control side to our experiment, adjacent to our experiment location. The southbound with the typical markings, we found an average speed of 63 miles per hour. And in the northbound direction with the orange, we found an average speed of 59 miles per hour with this one. So a 4 mile per hour reduction. So some benefit there with that. So again, we all know as speed increases, the risk of it being a serious crash increases as well. Right, and we do have a survey going with an existing experiment we're doing. So this is okay if anyone would like to take this. They decided to open this up to the public just to get public feedback. So you can scan the QR code now later, and there's 12 short questions there to give us some feedback on your opinions of orange markings. I think this will be available later if you'd like to go back if you don't have your phone out. And then kind of our research part of the presentation, our conclusions, we got positive public feedback. So, drivers in Indiana that took our survey are acceptant of orange markings on roadways. They'd like to see more of those. They're more visible. They make them more aware of the work zones. And then we're getting positive safety benefits. So we've seen a reduction in crashes going through these as well. And then also a positive speed impact. So it seems to be lowering speed slightly. So anything we can do to get people to slow down just a little bit more in the work zones is going to be beneficial. Right, and then I'm going to hand it over to Joe Bruno with NDOT.
All right, thanks, Michael. And I'll continue with a little bit of that research and then discuss some of the other topics NDOT's been researching recently. Right, can you see my slides?
Yes.
Right, great. Okay. So I'm going to continue with the contrast marking study that Michael Williamson finished for us in 23, and then our wider line implementation and our use of more durable markings, our plan and reasoning for our going to wet reflective durable markings, and then our rumble stripe research, which is we'll have another study coming out perhaps later this year, and our pavement marking friction testing research. I guess we implemented contrast markings for our freeways with concrete pavement. Rural freeways, we have this pattern where it's just for the lane lines, either broken or dotted, and it's a full shadow. So a 10-foot white line followed by a 10-foot black segment, and then this makes it easy for it to be done by maintenance in the future, potentially. Maintenance is looking at getting equipment so that they could maintain this with paint. Currently, we're not set up to do that though, but that's our plan for the future with rural freeways with concrete. In urban areas, we have also the bordered pattern on the edge lines. And we went with 1.5 inches of trim on each side. And this would likely just be done with preformed plastic or cold plastic or polymeric tape. Then on wider lines. So we have this, there are several studies that NDOT did with our Joint Transportation Research Program. There are also some national studies we looked at. So for the wider edge lines, we saw the 2012 study and Paul Carlson's study or Adam Pike's study on machine vision with 6-inch edge lines being significantly having a significant CMF and improving marking detection distances for machine vision, particularly during low ambient lighting conditions. We also at NDOT looked at the language in the NPA for the MUTCD and saw that it was going to require 6-inch lines for roadways based on speed. And we went ahead and implemented that for all of our state highway system with 6-inch as the normal width for our lines, and including lane lines and center lines, and then 10 inches as the wide line width, not 12. We're still trying to work that out with federal highway for our Indiana MUTCD, but it's looking like we'll just, at least for the time being, go with 12 and maybe go back to 10 in a future edition or with a revision. So on durable markings, as part of our review of our markings and how long they're lasting and our striping needs, we changed how often we're using durable markings. It had been 6,000 ADT, the kind of standard condition in the MUTCD for having a center line or edge line, and we went with the guidance figure of 3,000 ADT. We are looking at reducing that further to 1,000 ADT, or but still on the pavement surface life. So coming back again with another project, that would still be there at 4 years. And let's see, wet reflective. Again, we looked at a national study on the safety performance of wet reflective lines, and so they have a significant but more modest CMF of about 10% in terms of reducing crashes, relevant crashes. And so we went with wet reflective optics for all durable markings beginning in 2023, and pleased with the performance of that. There has been some issues with contractors. We may end up going, right now it's just a default. It's understood in our pay item that if it's state highway system road, it must be wet reflective if it's durable marking. We may go back to having that be kind of a supplemental description of the pay item, but we'll see. And then on our alternatives to raised pavement markers, this goes back, almost over a decade, to a desire to get away from center line raised pavement markers. They have been some liability issues with some of them in other states. We hadn't had that in Indiana, but we were concerned about it. So we looked at centerline rumble stripes as a potential alternative. And one district really took that where they stopped putting in centerline raised pavement markers. The others continued to do them. And so we have more research on that as I'll get to. And then, but one of the things we did implement as a standard treatment was centerline rumble stripes, where we had at least 20, you could say 22 feet of paved surface. We could implement centerline rumble stripes as part of the resurface project. One of the issues with that, though, was with noise from property owners that lived, adjacent to the state highway. So we looked at a quieter pattern, the sinusoidal pattern, and published a study in 2018 where we looked at different wavelengths of that, and the pattern we chose is the one that has the most effectiveness inside the vehicle in terms of vibrations and noise inside the vehicle for a variety of vehicle types. So we did test not just passenger cars, but some trucks as well. And it was most effective inside the vehicle, and did also result in very quiet outside the vehicle. It was not as noisy as the conventional rumble stripe. This is our standard drawing. So a lot of our resurface, there's no shoulder joint. It's just 14 foot on each side of pavement, and then, or if it's not quite 14 feet, it could be 13 feet on each side, or whatever the right of way is. And so there is difference in whether there's a shoulder joint or not, what the offset is, but the pattern for the corrugation is the same. And then for centerline rumble stripes, we have, and one other point I want to make. We have the study I mentioned earlier for rumble stripes that should come out either later this year or perhaps next year, is on this effectiveness of the sinusoidal pattern and the narrower widths. So we had originally it was 16 inches wide, the corrugation. We went to 10 inches for edge lines so that we could use it on more roadways. And I guess the research should show that they're maybe not quite as effective, but still useful with the narrower width. Conversely, though, for center line, since we went from 4 to 6, we increased the width to 18 inches of the corrugation. And we worked with industry on that to make sure that that would be okay, and they felt that they could handle that. So that's what our current width is for the centerline rumble stripe. And we also have gaps for RPMs as part of this study, the 2019 study, which was looking at some issues with RPMs and centerline rumble stripes. The other ongoing research we have right now is with centerline RPMs again, and going back to that one district that really stopped doing them, and the other 5 that has 6 districts, and so there are 5 that continue to use them and 1 that did not. And so we're looking at the safety performance of them on our highways. About, in terms of mileage, we have about 12,000 centerline miles, and then about 40%, a little over 40%, is under 5,000 ADT, and about a quarter of that total of 12,000 is under 2,000 ADT. So we have, Purdue is looking at the safety performance of those centerline rumble stripes, because the most recent NCHRP report 1015 on RPMs, has recommendations on spacing and placement and maintenance. It doesn't discuss a CMF in terms of, if the roadway is less than 5,000 ADT, should RPMs be omitted. There's an older study that kind of indicated that you could omit them when it was low ADT, that they weren't as beneficial. But we find that the public likes them. So anyway, this study will hopefully clarify where we should use them at INDOT. So then our most recent research, the study on pavement marking friction. So it looked at skid resistance for bicyclists and pedestrians in particular, but also longitudinal markings as well. And the research there, they looked at different materials and different beads, and found that, let me see, and also did a synthesis review of different standards in other states and other countries, and found that the minimum friction should be about 40 for at least bike lanes and the high visibility crosswalks. And so INDOT plans to implement that, where we have a minimum friction value of at least 40 initially. And then I guess on the bead type, I think the ceramic beads or angular glass beads can improve the skid resistance, and so we may specify them for the high visibility crosswalks that have the markings that people walk over, and also the green lane markings and bike lanes. I guess that's the last slide I have. Professor Williamson, if you want to share your screen, that would be fine again. We'll take questions.
I'll kick off one.
All right, Eric.
So, really interesting work. I love, all the data you showed. I love the links to the articles. I'm a nerd, so I love, getting all the gory details, but you did a great job summarizing at a high level. I'm curious for each of you, if you had more funding to improve something about markings in the state, what would you love to improve that you haven't gotten through yet? What do you think would add the most safety value?
I think helping locals with the wider lines. We didn't go, to 6-inch for them. We have a lot of local public agency contracts that go through the INDOT lighting system. They're still with 4-inch lines. I think going to 6 for them would be the best value. I looked to see how much, in the 2 years we've gone to wider lines, what the crash reduction we were seeing from that. And I think it'll be significant. I did, in terms of roadway departure crashes where they run off the road right, it looks pretty good in terms of reducing fatalities. So I think that's what I would recommend.
Tom, it looks like you're next.
Yeah, the question I have is for Michael related to the orange pavement markings. You mentioned you saw a reduction in crashes. What did you compare that to? Was that to a statewide average for work zones, or what comparison? Because I assume you didn't do both white or orange markings in the same work zone.
Yeah, so what both sites actually worked out, at Sellersburg, we had the northbound direction striped with orange and the southbound with white. Same, essential works going on in both directions of travel. So we had like a experiment side and a control side, and then the same at the Lebanon. Lebanon was more of a unique because it was at exit. So it had a before construction period where they had several crashes, and then they implemented orange as a kind of a countermeasure just to see if they could improve the safety at that location. So we had before and after data at that one. So we had kind of a before and after approach and then a comparison approach, depending on the site.
Thank you.
Great. Who's next?
Thanks a lot, Ron. When I'm thinking about some of the research that you're doing, whether it's the orange markings, rumble strips, and you have recommendations, are these required by the districts to adopt? Do you leave some of these as options for them to do for certain periods of time? How do you basically implement some of these successful ideas?
So orange, yeah, right now we can't implement orange on a wide basis because it's under experimentation. So we are supposed to send Federal Highway a list of where we're using it as part of our semi-annual progress reports. So we aren't doing a very wide usage of orange, but the other changes, yeah, that our MUTCD allowed, we can implement for standard drawings through our design guidance and get them used to potentially even on LPA, local public agency contracts. But yeah, that one's under NDOT's control.
All right. Well, then let me jump in. Joe, you've been doing this a little while. How many treatments or other experiments that you've seen have had kind of public reaction in such a positive way? I would think that 80% is a pretty good number.
Yeah, I was pleased with that orange marking survey. I agree. I haven't seen anything that else with markings or signals that I get involved in where the public response has been that positive. It is impressive that they're receptive to using orange to help with work zone markings.
A question about, you talked about edge lines, and you're talking about, it looks like you're talking about dropping when it comes to, what was that? Was that the 6-inch? You were talking about dropping it down to 1,000, or was that something else?
Oh, so that would be using durable markings. So we use multi-component thermoplastic, starting now at 3,000 ADT. We would be going to that at potentially 1,000 ADT.
1,000 ADT on the durables. Okay.
Yes.
All right. Brian, you're up. Brian DuPont.
Yeah, I was going to ask, Joe, you mentioned about it needing to go and get approval by Federal Highways to go and be used regularly. Is that something that you have recommended to Federal Highways based on your experience?
I don't know that it's ready for interim approval. I could follow up to see. Yeah, once it's under interim approval, then it's easy for states to apply for it. Currently, orange is only under experimentation, where you send a request and Federal Highway reviews, and then there's stricter reporting requirements, and it's not supposed to be used widely in the state until the research is done. So yeah, for orange, I would recommend jurisdictions to pursue that experimentation and get approval from their Federal Highway Division office before using it.
Excellent.
No, I was more focused on is Indiana making a recommendation to Federal Highways to go and accept orange as a alternative marking?
So at this time, like we've extended the research, we're doing a second phase. We've been doing it on where we're shifting lanes at night. We're not ready yet to submit our recommended language to the MUTCD. That research, I guess, Michael, you can answer the time frame on that, but we would be looking to do that at the end of this continued research.
Yeah, there's not quite 2 years left in that project before we'll have the report published.
Joe, you talked about if you had more money, one of the things you'd really like to do is work with locals on 6-inch. What is your edgeline policy at the local level? Is it, I mean, what is the ADT? I know Missouri is as low as 400 for edgeline installation. Is Indiana similar, or is there a difference there?
So on the state highways, we put in an edgeline regardless of ADT. Locals, often it's more of a pavement width concern where if it's not quite wide enough, but they have many highways where it is wide enough for an edgeline and they don't put them in. And so it varies by jurisdiction. And so I would say that many rural county highways should have edgelines and don't.
What is the one thing as you started looking at things like 6-inch lines, what's one aspect of say a pavement marking that you're continuing to look at? I just saw a study out of Alabama on safety derived retroreflectivity. Is that something that you all are beginning to look at, or is there some other topic as it relates to markings that you're interested in?
There is another, I think we're interested in temporary markings. We have another study starting on temporary marking materials that we'll be doing, over the next 2 years. I guess in terms of safety, I think I would be interested in maybe looking at that friction research again to see if there's a safe, more than just like for pedestrians and bicyclists with run off the road for longitudinal markings, if that would be something that we started using more skid resistant coatings and beads, if that was something that had a safety benefit.
Excellent. Excellent. Well, any other questions for Joe or for Michael? If not, I want to thank you both for taking the time. This is, we've been very fortunate through the National Committee of being able to see presentations on the Orange before, but I felt like this was important to get what Indiana is doing in really trying to link research and programmatic change as you're moving forward with your program. And there's a lot of questions left unanswered as it relates to the new machine vision. So I want to thank both of you so much. This will be available. People will be able to watch this on our YouTube channel and on our website. And so to both of you, thank you for spending time with us today.
Thanks for the opportunity.
Thanks. Yep.